Hello, everyone. Thank you once again for joining us today for the second section of reproducibility. So I'm going to take us through a bit of introduction, and then I'll hand over to you. As usual, we are quite grateful for ORG that has provided the funds to support our training section today. And we are also very grateful to our trainers who have volunteered despite their busy schedules to support us with this training. As usual, Aaron has a code of conduct, and we hope that everyone will be able to adhere to it during the sections and out of sections all our platform. We encourage you to embrace diversity. We are all coming from different backgrounds, perspectives that others have. We promote constructive communication. Make sure that whatever you say is in a constructive manner, because we all come from different backgrounds and different views. And people may have different views, but kind of communicate, make sure you are doing in a constructive manner. We also foster collaboration and sharing. There's an open platform. Feel free to share your ideas and thoughts about anything, and the community will be happy to help or support you with that. And we also want to ensure that you conduct yourself in professionally every way. And if there are any violations or issues with the code of conduct, if anyone violates this, send us a team at second.org, or you can use the incident report form, which is in the link, the slides, and the shared links, documents, and just send information or whatever happens. Thank you very much. I'm going to hand it over to our training to Susan.
Yes, hello everyone. I'm going to share my screen also. So I hope you can hear and see everything. So welcome to part 2 of our training on reproducibility. So I have included the link to the slide deck again and the shared notes here. So the shared notes is also in the Zoom chat. So I'm Susanne Auer, and I'm a plant biologist and lecturer at the Technische Universität Dresden. That's in Germany, really in the eastern Germany. And you can find me also on LinkedIn if you want to connect. We are, as Reproducibility for Everyone, a community of scientists in academia and industry who want to improve the reproducibility of science, and we have members all over the world. If you want to see more details, we also have a website, reproforeveryone.org, or you can watch the last recording on that. So I want to thank our past sponsors again. We were lucky enough to have some funding for our efforts in the past, and now we are currently moving forward, thinking of new ways to be sustainable as an initiative. So this is the link to the paper we wrote, and all of that I told you at the last training already. Please mute yourself if you can, so we don't have any issues with interference, or that one of the moderators have to mute you. So our code of conduct is listed here. It's very similar to Aaron's code of conduct. So we do not accept any interruption or disruption of others repeatedly. We don't want to have anyone give unwelcome attention to someone, to bully, discriminate, or harass, use sexual language or imagery, or make fun of personal appearances or choices. We want to be an inclusive, respectful community, give everyone a chance to contribute, and therefore we try to use inclusive language. I'm still learning on that front as well, so I'm constantly trying to improve myself, and you feel free to correct me if you feel I did something wrong here. We appreciate and accommodate differences, and we try to lead by example, so this is what we try to do. If there is anything coming up in this training, please write a private chat message to Nele, or you can contact us over this form. So for communication, like last time during the webinar, please use the Etherpad. So that link is always on the bottom of all of these slides. If you put your question in the Etherpad, I can see it and answer it. So I'm not active on Slack all of the time. I don't use Slack each day. So if you post any kind of question in Slack, I tried to find that one. If you have another question in the Slack, and please also tag me at Susanne Auer, or otherwise I might miss your question. So please, if you can, use the Etherpad for your questions, and there we will answer the question as best as we can. And there you can also read it. So this Etherpad will be available to you also after the training is finished. You can always visit this one again. Yeah, so it's going to remain active and online. All right, so today we have the second part of our training, and we have now a few kind of learning objectives, some goals we want to achieve today. So the first is we're going to hopefully learn about reproducibility, the reproducibility crisis. I hope that you find the chance to learn about types of reproducibility in research, understand the ethical implications of irreproducible research, and be able to identify future directions in reproducibility. So these are our goals for today. And so the last time we already talked about some factors that decrease reproducibility. So this is just a reminder of what we covered the last time. And so when we talk about now about these kind of issues, why is there a crisis of reproducibility? I just want to remind everyone, of course, in science, in research, we have a natural variability of the kind of models that we study. When we question people, when we do questionnaires or surveys, the kind of cohort we question will be different, very likely, right? So we have some variability anyway. So there are some, we call them technical factors that can interfere with reproducibility. And so that means that it can be possible there's no 100% reproducibility really, because it cannot be achieved also statistically, right? So I just want to put that as a reminder. What we try to focus here on is really the human factors that each one of us can influence. So this is what our training tries to do, to really try to help you to be aware of your biases and of these kind of things that we can improve. And then, of course, if we have the power in our career at some point to work on rewards and incentives on the system, so to say, that would be, of course, perfect, right? And then this part here, study design and statistics, that's also something we can work on. So we try to focus on the achievable stuff that we can really influence. And we try to accept that there are some things that is not in our control, basically. So the reproducibility crisis, also called the replication crisis or the replicability crisis, this term is kind of used for the same thing. This crisis originated in the 2010s, so a bit more than 10 years ago, when there was, as it seemed, quite a lot of substantial important findings from the social, behavioral, and biomedical research that could not be reproduced by other scientists. And one of the main reasons were methodological flaws and also some publication bias. And so that led to some skepticism of the validity of research and a crisis of confidence. So I linked a paper here, if you're interested in reading a little bit on what is the origin here. Romero in 2019 has basically a list of 4 things that triggered this kind of crisis. So why is that a crisis in general? So when we do research, we do the scientific method. So we use our intellectual honesty and logic and our previous knowledge. We study a lot of stuff. We kind of equip ourselves with knowledge then to use that scientific method. So we have a hypothesis that we want to test, or we do explorative research probably. And so this kind of scientific method depends, of course, on the ability to reproduce empirical results. So when we do research, we want to plan it in a way that we can repeat the same thing on the same data and with the same methods. That's what we said last time, which is reproducibility. And we want to have the same result. And then we will probably give someone else our research, or someone else reads on that, and they try to also replicate what we actually did and also come to the same results. So that would be a reproduction of empirical results. If this fails, if I'm doing my research and I do exactly the same thing again and I'm not able to get the same result, then I question myself and I'm like, okay, so what did I do wrong? Were there any parameters that changed or what's happening here? And if this is happening on a larger scale, as you know, when people write a manuscript and they publish on their results, there are some reviewers between that question stuff. You have to repeat your results or you have to repeat your analysis or your research for a couple of times until you can be confident and say, okay, this is the result and this is what we have here. So if this fails, if the scientific method that we use to the best of our knowledge fails, that can lead to a question of, or that can lead to people questioning the credibility of probably a theory that was developed based on these results or on scientific knowledge in general and how scientific knowledge is accumulated due to the scientific method. And so there were, as I said, a couple of events, some very important findings where people were just not able to reproduce these kind of previous results. And so that was a question, okay, are the theories we have here, are they even valid? So that was a huge crisis then in the confidence of these findings. And so this is where some say it's a perceived crisis, it's not a real crisis. This is where this crisis comes from, that many scientific studies in a certain area, and also before, were difficult and impossible to reproduce. So this was a very short kind of summary. If you want to read a little more on that, please check out one or two of these papers here that I listed here. And also check out the event that the UK Reproducibility Network does this Friday, I think. No, Thursday, Friday, something like that, on the 18th of April. So there they will also have a workshop on different fields and reproducibility as a whole. So one big issue that was seen over the course of also basically the last century in the 90s and later on was that we have this publication bias, which highly contributes to this reproducibility crisis. So what does mean by that? Fanelli did an excellent, hindsight experiment, or what he did is he analyzed a lot of findings from different disciplines and from different areas. So you can see here we have the US, we have the European Union, we have Asia, and then here we have other countries. And he checked how much of that research was actually testing hypothesis and confirming hypothesis. And so you can see here the positive results of the research were always here. We see in the US, we start at 70% of what is in the literature, and this trend just goes up. So what this means is that the research that is published is the positive results only. Right? So it's like, okay, this is our hypothesis and this is what worked, and there we have it, ta-da. And you see that's the same. It did also, this is what had happened also in the European Union and what happened in Asia and also in other countries. So the negative results, basically, a manuscript or a paper describing, okay, we did this and this, and it did not work. They are disappearing from the literature. And this was what happened from many disciplines in many countries. And this is what we call a publication bias. So this is a problem because the values of the scientific community are transparency, first of all. So being transparent when you have done research, to be transparent about your results. So if you go to a conference or if you publish a paper saying, okay, so this is our methodology and this is what came out. And that should be independent of if something gave a positive result, if it was a confirmatory result, or if it was a negative result. So transparency is one of the cornerstones of science. Also openness about what you have achieved. You did research, what came out of it, being open about these kind of results. And then, of course, reproducibility, where you're able to reproduce your own findings. So these are some values that we should have as researchers. But the current system, the current scientific reward system, favors innovation and not verification. So the rewards you get in science are usually for your career that you are you're first a student, and then you have a PhD probably, and then you do a postdoc, and you travel up this kind of ladder, this career ladder, due to the research you do. You publish a lot, and maybe you have some really great findings. And this is what kind of is right now the current system. So people who do good research and have like these very exciting findings, these are the ones that get promoted, and not necessarily people who probably verify something or who are very tedious in their work and who work really long and very specific and really look into the details and do really good science, but don't have these kind of amazing results. They are verifying something. That's not usually what is rewarded right now. And so that kind of bleeds a little to this topic that we have not so many null results, so confirmatory or nothing has happened results, but we have a lot of positive results. So we have this bias towards positive results only. So there's a lot of results and a lot of good science in the file drawers of people's desks, basically. So people did science, but they're like, no, I cannot publish that because it's not exciting enough, because the paper's rejected. And so that's not really happening. And so there's a lot of science buried in some file drawers, which probably never sees the light of day. So in general, in life, of course, it's good to accentuate the positive, but here in science, it's not so good to only focus on the positive results. So what you see here, this is a figure from a great article from Ed Yong from 2012. And so this is the literature analysis across disciplines, different ones. So you can see basically we have the physical, biological, and social disciplines. So we have here different representatives of that. And what we see here is the proportion of papers supporting the tested hypothesis. You see in psychiatry, psychology, where this replication or reproducibility crisis originated, basically, you can see here we have a lot of research that is confirmatory or that is only giving the positive results. So people are writing up their research, they say, this is the hypothesis we tested, and hey, voila, it worked. It has worked as we thought, right? So that's also statistically very unlikely. So there is this bias here. And this is, again, to sum up the crisis, this is where we were in the 2010s. Now, psychology has turned a page. There was like the pain point was reached in that kind of discipline. And so now a lot of colleagues in psychology, they really try their best to do pre-printing and pre-registration of studies. So a lot of colleagues in psychology are now tackling this kind of crisis. So another level, another kind of layer to that is that non-replicable publications are cited more than replicable ones. And this is very recent research. It's from 2021. So what you see here is if you read this little abstract, what they did is they used publicly available data to show that published papers in psychology, economics, and general interest journals, they fail to replicate are cited more often than those that replicate something. So it's not only publication bias for the positive results, it's also, if you read here at the end, because then you can think, why is that? Why are papers with findings where we know they are not replicable, why are they accepted more in publication? And they assume here, and this is a bias thing, that when results are more interesting, whatever that means, the reviewers apply lower standards regarding the reproducibility of results. So if we have reviewers who review the paper, which are the gatekeepers basically also often on if a paper gets published or not in the journal, reviewers, when we work as reviewers, we have this bias of, oh, that's a cool result, that's a good finding, so I want to believe that, and this is why I kind of give the green light, and that manuscript gets published. Even when people know that something is not replicable. What I found interesting on reading on that is also, and I read that on various kind of occasions, existing evidence shows that experts predict well which papers will be replicated. And so this is something, if you're experienced in your field and someone, like you have a student and they propose a project to you, or someone's writing up there the manuscript, if you're experienced already, you will have a feeling for, okay, this is going to be, that's a cool result, but I don't think that this is replicable because based on your experience and what you have seen in your life, in your research life. So people are well able to kind of specifically when you are more experienced to get a feeling for what's replicable and not. So that kind of bias is also there, right? So yeah, this is something we should keep in mind. It's probably a human bias. I'm not a neuroscientist, so I don't know so much about the human brain. So I don't study that. But I think it's good to know for all of us, we have these biases. And so maybe we should kind of adapt our behavior. Now, ethical implications for irreproducibility are a lot of different ones. I just listed a few here. First of all, of course, there's a waste of resources. If you go into literature, you try to replicate what they did, and then you're just not able to. And even if the methods are maybe written up really well, but maybe some key ingredients missing or the weather is not right for you or whatever it is, it's a waste of resources, of course, and time that a student or you invests in replicating something that is not replicable, in the money that you have to spend on that research, and of course also in people as a resource. So if you make your students doing some replication experiments and they are failing, of course you learn, okay, that cannot be replicated, but you basically probably wasted a few people on that in a way that maybe these people are also very unsatisfied with their work then. We have the issue that the more and more research that is not replicable, the more and more people feel that maybe science is not right or they don't trust the scientific method anymore. And so that can lead to a mistrust in science on a more global scale also. So that people who say, okay, I read that in a newspaper, but I don't trust science anymore. And so that's kind of a really kind of dangerous part to be in, right? And then if we go into clinical research, that's actually where some of that crisis also originated in. There was a company, a biomedical company, and they tried to build a drug based on what was published in the literature, and they had a very low replication rate. So they could only replicate like 10% of what was in the literature. And so they wrote up a paper about that. And that also started a huge kind of ball here. So if you think about in cancer research, that's what we saw last time, a week ago, more than 50% or so of really high top kind of cancer research studies were not replicable. If you think about the implications when you treat patients with a method that is in the literature, it looks really good, and then you probably use that drug as a doctor because that's what science said, and then it's not working because it wasn't replicable, or maybe the findings were wrong. That, of course, is a huge, huge issue, yeah, because then we have potentially harmful consequences for the patients. All right, so what types of research reproducibility do we have? I'm going to make that relatively short because Nila is going to talk a bit more in depth about some of these, but I want to kind of list a few things. Here, in general, all aspects of research play into reproducibility. So whatever you're doing, how you're documenting, all of these kind of things can also be looked at through the reproducibility lens, basically. So if we are in a laboratory environment and you used to record everything with your paper lab notebook, it might be a good idea if you can, or I just want to tell you in case you're not aware of that, to document your stuff in a laboratory with an electronic lab notebook. So these are basically, these are software tools that are developed by companies. Here in Germany, there are some institutions who are well funded, like Max Planck institutions. They program their own electronic lab notebook softwares, but there are also a lot of companies who sell these kind of software right now. And so what the kind of benefit here is, you have a digital documentation of your laboratory experiments. So like with many digital tools, you can, first of all, you have here a good kind of course structure. So you can have like certain methods, for example, which you can just copy, and you give access to your students to these kind of method descriptions and collections here. So you have a good data organization here. You have some Office compatibility, so you can export your document or print it or do something with that. You can search this document, which is really valuable. If you have done your lab documentation with an electronic lab notebook for some years, of course, it's good to search back, okay, where did I use that? Yeah, and each entry is dated, so that's also nice, specifically for companies who are sometimes also very interested in document these kind of things. So that happens kind of automatically. So the benefits of using an electronic lab notebook, of course, is the searchability. You can export your stuff. You can easily share it with collaborators and the broader community or within your working group. You have access theoretically globally. You can embed high resolution images. So this stuff is usually stored on a server. And these solutions require money, usually, that you have to pay for them. There are also free versions available for many lab notebooks where you can first try out a free version and then they store the stuff on their clouds. But then if you really like want to have the full usability, you usually have to pay for these kind of software tools. Here's some more information on the link on the usability of electronic lab notebooks. So that's something that's maybe worth considering. Now, computational reproducibility means everything that has to do with people who do a lot of programming or who use code in their research. Even if you're using Jupyter notebooks or you use R a lot, the R language, or maybe you use Python or some other kind of language. So here we recommend literate programming, which means that first of all, when you do your code pieces, you heavily comment your code. So you do a lot of comments in between your code to explain which code chunk is basically, well, which code chunk does what and why you use that. And then you should store your executable code together with your analyzer's narrative. So you should also in your comments write, okay, I did that here because of that. And this kind of literate programming, if you start with programming and you do it like this at the beginning already, that really saves you a lot of time half a year later when you get back to that original code and you do not know anymore, you don't remember why you wrote that piece of code like that. If you have heavily documented and commented your code, that will make it much easier for you. And then there's container technology where you basically can put everything, your whole coding environment into a container. So that kind of technology enables you to basically have a closed environment of what you did there and be able to repeat your analysis in that kind of environment. So this is something we will look on in level 2. There are other types of reproducibility, of course, so reproducible methods and protocols. There are reagent repositories if you are a chemist, for example, or if you are a plant biologist that creates new plants. So for example, in my community, people are working with methods, specific model plants, and then they have seeds of these new plants they developed. That's something you can share with our repositories. We have data sharing that you can do over data repositories using good metadata. And then there's pre-registration of studies and preprints as well. So that's just a few of these. And now I'm handing over to Nele.
Great. Thank you, Susie. Yeah, so my name is Nele. I'm an assistant professor at Baylor College of Medicine, which is in Houston, Texas. Just like Susie, you can also find me on LinkedIn. Today, I'm going to talk a little bit. I'm going to continue on the theme that Susan just introduced, and I'm going to talk a little bit about the future directions of reproducibility. And so this is a wave that started maybe about 10, 15 years ago, but that is still really going strong, and talks really mostly about sharing everything that you need to be able to perform an experiment in whichever field that is. Next slide, please, Susie. So Susie already talked about this before, but reproducible research really depends on understanding exactly how and where and with which reagents experiments were performed and how that data was acquired. And so to be able to do that, there really are two critical elements that can help improve reproducibility. The first one is increased transparency and sharing of anything that you need for your research, all the reagents, the methods, as well as the data. And the second one is to actually have access to that. So accelerated sharing of those results. And this can be in the form of a preprint. Next slide, please. So I put all of those together here. What does that mean when I talk about accelerated sharing of research resources? This is really anything that you have used for your experiments. So these can be the data sets that you've generated, the reagents that you've used, like Suzanne was saying, whether they are seeds that you have collected from the new transgenic plants that you've created, or they are plasmids that you've cloned yourself, or they are fruit flies, anything that you have used, whether it's an antibody that you made, anything that you made that is different from what's publicly available, you can deposit at repositories so that they become publicly available to anybody else in the field. If you are in the computational field and you've developed some scripts, those are essential for anybody else to be able to do the same thing. So those should be shared and they should be annotated, like Suzanne was mentioning. And then you have very crucial methods. There's a great need to share not just the small section in your materials and methods section of the paper, but to actually think of your methods document as a publication on its own, and to share in a very detailed way exactly how an experiment was performed. Those can also be deposited at a repository. And then finally, papers themselves. It's really helpful for researchers to have accelerated access to research as it's being performed, rather than having to wait until the paper is published, which sometimes can take a very long time. And so I put some examples of the places where those can be shared at the bottom. It's okay. you can stay on that slide. For any of those elements, what's very important is that these elements are shared in a fair way. And what that means is that they're findable, accessible, interoperable, and reusable. Findable and accessible means that you can go to the next slide, Suzy. That you as a researcher are able to find these elements, whether it's a data set or a reagent or any of the other ones. And this is best done by using an open access repository. Open access means that anybody is able to access whether it's the data or the research reagents, and usually doesn't have to pay for it. There can be small fees related to it, but they are usually kept nominal. The second two elements that, for instance, for data, it has to be interoperable and reusable. This means that someone has to actually be able to understand what it is that you've deposited and be able to use it themselves. And so this often comes with a set of standards that you need to comply with when you are depositing, whether it's your data or your reagents. Next slide, please. So I'm going to just start with data sharing. And so here, these are often shared at repositories. Those can be generalist or specialist repositories. Generalist meaning they accept data from any research fields, and often also accept any file type. And then specialist repositories are specialized, whether it's related to the field of research or the file type. And so I gave an example here for a file type specific repository that accepts single cell RNA-seq and transcriptomic data, which is GEO. Often these repositories come with a set of requirements that your data has to comply with, and a curation team oversees that process. And so these can correlate to the format of the file types. Here often data repository really promotes you or prefers you to use an open format so that it's not a format that, that, for instance, you can only use if you have paid for a specific software on your computer, but instead it's a format that you can use with a freely available software or platform that you can download from the internet. There are often fees to deposit your data sets, and these depend on how large your data set is, but exceptions do apply. So please make sure that you look into that. It is important to if you want to share your data set, to actually think about that on beforehand and go look for which repository you want to use before you actually start collecting data, just so that you know. Often the minimal requirements are quite similar between these repositories, but you want to have an idea of what they are before you start, because often you can incorporate that in your data collection scheme and make your own life quite a bit better. If you want to look at fair repositories that comply with those principles, or types of standards and policies, you can click on that link and go browse around for one that's applicable to you. Next slide, please. Sorry, the little one woke up. No, not right now. Okay, so I wanted to give a very quick reminder for last week. When I'm talking about these standards and these types of requirements to comply with, they are often embedded in the metadata of a specific data set. And so this is the parameters that are important for, here I wrote future me, but actually it's for any researcher to understand how the experiment was performed. You can go to the next slide. And so when this is exactly what I mean, if you develop your metadata spreadsheet that has the information that you need to understand a data set, so which species your experiment or which organism your experiment was performed in, whether it's relevant, the gender, the date of birth, a unique identifier, the types of samples that were collected, when they were collected and how, those are elements that will also translate into the metadata file that is related to your data set. And they will also typically translate into the data dictionary that you will upload along with your data set. Next slide, please. And I'm going to keep this pretty brief because this might already be a little bit too advanced for an introductory class, but I just wanted you to be familiar with this definition of the data dictionary. And so this is a collection of names, definitions, and attributes about the data elements that are being captured or that are used in your experiments. And so they just help once you upload your data set, they help other people understand how it was done, with which organism it was done, and it helps you find related data sets on the repository. So let's say your data set was collected on the heart in a mouse. Those are labels that will be added on top of your data set when they are shared on the repository. And so if anybody else goes in and says, oh, I'm doing research in this field, let me go see what kind of data is publicly accessible, and you put in a search bar mouse, hearts, and whichever other label, those will help you pull them up. And so they help reveal, or they help create connections between data sets. Next slide, please. So the next element is protocol sharing. Here we will also go into a little bit more detail, probably in one of the future sessions, but I just wanted you to be aware of the importance and the possibility to openly share your methods. And so you're probably quite familiar with these feelings of trying to find a working protocol and trying to adopt a new protocol into your research or your lab, and just not being able to make it work, whether you don't have enough details about how it was performed, or maybe you're not using the exact same reagents. It's very hard to figure it out. And so very often you end up like the example with the trumpet there, with a very different result than what you anticipated, even after months of trying. And so that can be quite frustrating. Next slide, please. So to avoid that, there are now quite a few protocol repositories. Some of those are listed here. There are also quite a few journals that are now really focused on publishing methods. And so you can go explore these links here, but we will go into this in more detail in the future. But it's incredibly valuable to just think about sharing your methods with the broader scientific community, and it really helps improve reproducibility. And so here I'm giving you one example, which is for protocols.io. I like this platform for several reasons. It has a versioning ability. So you can see here, this is Western blot V1. Should you over the years make some changes to how you perform an experiment, you can upload a second version and let researchers know that it's still, the base is the same, but you made some modification. You can also click whether this works for you. And so you can, when you browse through these protocols, you can go find which protocols other people have used that have worked for them. And so this gives you an indication of how reproducible the method is and how well it's been described. On this platform now, you also have the ability to run the protocol yourself. And so it sort of keeps a record. You can, if you make small changes, like let's say you have a 30-minute incubation and it became 45 and you put it there, it stores it that way for you. So it has some features of an electronic lab notebook as well now. And then you can copy or fork it into your own workspace. And so these protocols, once you create your own and you publish it here, they become openly accessible to anybody. So you can go read them yourself, whichever one you would like. Next slide, please. Okay, the last one that I want to cover is manuscript sharing. And so this Suzanne also introduced before. This is related to the preprint movements. And a preprint is a PDF version of a manuscript that you've written up that you are planning to publish, but you actually share it with the scientific community and with the world actually before it is published in a journal. There are several reasons why you would want to do that, and I'm just listing several here. The first one is because it really accelerates science and it allows researchers to build on these findings before by skipping actually the lengthy publication process. And you could see the importance of that during the pandemic when researchers were pre-printing their manuscripts and really allowing much faster progress towards scientific solutions for the pandemic. It also accelerates careers because you can upload your preprint there, and if you're applying for a job, people can actually go read the work that you've done there. If very often you are at the point when you're ready to start applying for a job, but you still have, let's say, those 1 or 2 papers that haven't been published yet. They're ready. You're just in the middle of your reviewing process. So that can be very frustrating and can cause a lot of lost time for early career researchers. So by pre-printing it, you actually skip that step because you do receive a DOI that you can put on your CV that people can go look at. The third one there is that it promotes equity in the research atmosphere, which is also really important. By now, there are very high fees to publishing papers in several journals, especially if you want those manuscripts to be open access. And so you can bypass that by putting the preprint. The last one that didn't make it on here is that just to build up Suzanne had mentioned before. So actually helps remove the publication bias. So here, oh, my internet is unstable. Can you still hear me?
Yes,
Hear me
we
okay? Okay.
yeah.
Yes, we
Okay. So basically, any negative results that are harder to publish in journal in some scientific journals, the preprint servers don't have that bias or preference, and so you can publish your results there. And so you do see quite a few negative result papers now being added to preprint servers. I see that we are running low on time, and I want to leave some time for questions. I just put here, there are a ton of different types of preprint servers. You can go find which one is most applicable to you or to your field. On the right, you can see how the preprint movement has really caught on. And the last slide I had here on this topic this is a common question that researchers often have about preprinting their manuscript is if you afterwards go and try to submit your paper, if the journal will still accept it related to novelty. And you see at the bottom that more and more journals are allowing preprints and still are okay with reviewing content, even if it has been preprinted. Next slide, please. Okay, here are some links for you in case you want to learn more about it. And as our main conclusion, we really just wanted to emphasize that accelerated and fair sharing of all of the research resources you need to perform your work will actually increase the reproducibility and rigor of research. And so with that, we have covered our entire slide deck today. These are a couple of points that reproducible research practices will help you with. They are elements that we will go into more depth into our next sessions, and they will give you a bit more practical tips to actually implement into your daily life. And with that, I think we can move into the Q&A section.
Yes, definitely. Thanks a lot, Nele. So we are at the end of our part 2. Thank you everyone for being here and listening. As always, you find our slides. Let me just circle back to our link here. So here in the Etherpad on the top, you also have the links for where the slide decks are. So I'm going to stop my screen sharing now, so we can have a bit of a discussion. And yeah, if there's anything troubling you or
any questions, any comments?
Yeah.
Was this too much content for today? Was it a bit too dense? Was it okay?
So you can also let that kind of new input sink in and use the Etherpad and add more questions there if you want. As I said, that's going to remain active also for the next couple of weeks, probably months. Okay, let me check the chat here. So I see some people are have been joining by smartphone. So I'm interested, maybe you can put that in the Etherpad. When you are using your phone, can you even access the Etherpad well? Because then you have to switch between the Zoom app and the Etherpad, right? So for everyone using your smartphone, I'm interested in your experience in following these kind of Zoom talks. Or you can just raise your hand and talk to us if you want.
We have a question about dataset storage platforms, if there are free ones out there. To upload your data, I don't think so. I think most of them will come with a fee. I am not entirely sure, so you would have to go look around, and I'll add the link that I put in the slides to find fair repositories. There you go. So most of them will have a fee for you uploading data, but there are really exceptions. So they often have, if you go look at their process, and I think for researchers from the African continent, these exceptions will more easily apply than, for instance, for me in Houston. So you can go look at those details and see if you would be able to request an exception.
There are also sometimes institutional servers where you can deposit your data. Again, I think that depends, of course, on funding. We touched quickly on that last time when we talked about cloud server storage and how, so in Europe, as I said before, most institutions, well, if they want, like universities, other institutions, if they want their researchers to actually keep the data and a lot of data, they will provide that kind of service. And I hope that's also going to happen for your institutions. And the same is with data repositories. So I'm employed at a technical university. So that's a bit of a specific thing where they focus more on also providing infrastructure and technology. And so that data storage option, that data repository that my university has, so they have their own data repository in the county that I'm living in. There I could deposit my data for free, as far as I know. So that these kind of things are also possible. And I think there are, if I'm not mistaken, there are data repositories, as long as the data set is not super big. There should be some options, I think, where you can probably use them for free even.
And there was a question about journals publications policy and which ones will accept preprints and still review it, or which one would reject it based on loss of novelty. So I put a link in the chat that is from ASAP Bio, one of the organizations that really has been pushing the preprint movement forward. And so they have a list of a bunch. I don't want to say all because there are way too many journals by now, but a list of really a lot of publications or journals and their publication policy.
Yeah, so there's a question, what is with osf.io? So depends on what, Michael, what kind of context you ask that question of. So OSF is also basically, it's a resource you can use, which is for free, as far as I know, for anything where you want to deposit text or anything. So this is a great place also to put your preprints on. So the OSF can even be used as a bit of a mixture of a lab note documentation and depositing a manuscript. So what you can do with the Open Science Framework with osf.io, if you have an account there, you can have your own project where you have some manuscripts or some PDFs you put there and set that to private first. And then when your project is finished, and you want to publish that and you want to have a DOI, then you can press publish, basically, make it open for everyone. And that could also be where your preprint is depositing. And then, of course, nowadays in the age where we live in, it's a good idea usually if you have a preprint out, that you actually try to promote that over some social media. So LinkedIn, or I'm not sure what you guys are using. So alert other people that you have just posted a preprint, basically. So people also are able to find that, because that's what many people right now do. Many scientists now also use social media to say, hey, I just published this article there. And so that's good also to keep the discussion going. So Ernest was asking, at what point can I share my preprint manuscript and which journals are ready to accept? Yeah, so that's what Nele has covered, I think. So basically, a preprint, you can at all stages, you could publish a preprint. I have a colleague, and I think he said it nicely. He said, it takes guts to publish a preprint. And by gut, he meant as in, it takes some courage, because a preprint should have a high quality. So if you are writing up a manuscript and then you get it ready for publication, the text should be as good as you can. Your figures everything should be perfect. And this is what the preprint should be as well. So just think of it as you write up your manuscript and you want to deposit that with a journal. This is what you can put up as a preprint. Really a perfect, really a good version of your research findings with enough context. Of course, you can also just deposit a preprint which doesn't have a good quality, but that will damage your reputation if you do it a lot of times. Because a preprint, when you post that, just like a journal article, it would get a DOI, so it will get a permanent identifier, and you cannot delete it anymore. So it's published, and that's what it is. So everyone can see it for the rest of eternity, basically. Not really so long, probably, but you know. So you really make yourself also a little bit vulnerable by doing that. So it should really be a good version of your manuscript that you publish as a preprint.
There was also a question about pre-registration versus preprints. So I tried to cover that in the chat. With the pre-registration of your study, you actually have reviewers comment and review your research design before you start all of your experiments. And so that's different from the preprint, because that actually happens after you've done your work. So with the pre-registration, once the journal decides that they accept, they are interested in this study, they want to learn the results regardless of what they are. So this is a something we can maybe cover in the next session, but this is a new concept that helps to avoid the publication bias, because here the journal will publish your work regardless of what the results are. It does come with quite a bit of work to go through before you can actually start the work, because you have to have people review your experimental design before you can start. And so with the preprint, you have done your work, you have done your experiments, you've analyzed everything, and you've written up your manuscript. You just share it with the community before you start the publication process. And there's a question about research verification policy. I don't know if you want to expand on that a little bit, because I'm not 100% sure what you mean by that.
Hello,
Can someone not?
Susan and Nelly. Is that mine? We've exceeded the time that we agreed on. I don't know if you'd like to add a bit more minutes, if it's okay with you.
Yeah, sure. There are more questions also, so I copied some into the document in the Etherpad, so everyone can read them, because the Zoom chat, I think, is not available when people watch this recording again. And can someone not copy your work from the preprint and publish? So that's one of the things people have afraid about. So a preprint is a published version of your research with a DOI and a timestamp. So if you publish your research today on the 15th of April, 2024, and then another researcher comes and would repeat what you do, and then they hand it into a journal and all that, that takes longer for them. And then maybe in September, that kind of paper would be published. You always have proof that you did this thing because you published your findings already on this 15th April of 2024. So the other person then would have issues explaining why they are not the same author, why they have copied your work. So of course people can do that, but because you have a timestamp when you publish your preprint, it's clear for everyone that you have been the first person to do that, and this was your research. So a strategy that many researchers do with preprinting is the following. Many people are writing up their manuscript article, and then when they are, at the moment that they are submitting to a journal, they are also depositing the preprint. So people are publishing in journals that accept any kind of science that has been preprinted, like the ones that Nela has shown you, for example, +1. So they hand in their journal, they hand in their manuscript to the journal, and at the same time they preprint their science. So what happens then is you always have the preprint, so everyone could read what you have submitted to the journal. And then if it's successful and the journal has, usually then the reviewers will ask for some clarifications, you have to change your manuscript a little, and then maybe it's published in the journal at some point, but everyone can already read basically what you tried to say. So that would be, the journal version is then the second version of your research basically, and all of these preprint servers, they will link to the then published, reviewed, peer-reviewed paper. So you always have then these two versions. Yeah, so this is something that many people are doing. Yeah, and it's good, you know, no library wants to pay these huge amount of fees to have access to research, which is not open access, right? So if people are doing pre-printing more often, it's really, as Nella said, you instantly have access to what people have been doing in the lab. And then you are also cited more often. So preprints are citable because they have a DOI, they have this permanent place where they live in the digital world somewhere. And so other people can cite your work for the preprint. And a last factor that I think is important, if you are an early career researcher, you are a PhD student, and maybe there are some issues with your boss, or you try to publish something and then maybe there's a power imbalance and someone's trying to stop you from doing that. If you're the one who did all of the work for method development, for example, you could then, for example, write up your methodology, share it as a preprint on one of these protocol servers, and then you also get the credit for your work. Yeah, you don't have to kind of rely on maybe someone that's more powerful than you that would try to take your research and run. These kind of things happen, of course, as well. So this is something that also is, I think, a big bonus and a big benefit of preprinting. So it's 7 after our original finish time. And I'm just going to address the last comment here. So maybe we can also copy that over to the Etherpad. How reliable is the preprint? Is the work evaluated? Not per se. So posting a preprint is just you publish something, no one will evaluate it. However, there's a journal, eLife, for example. eLife now only peer reviews anything that has been pre-printed already. So the journal eLife does not take up any more submissions. You cannot submit any kind of manuscript to eLife. They only review any kind of manuscript that is already a preprint somewhere. So having a preprint does not mean no one is looking at your work. Actually, under a preprint, you can see comments. Everyone can comment on your work. So sometimes there are a lot of discussions under a preprint, like, hey, this is like, can we ask you a question? Can you clarify that? You can also update your preprint. So you have your version there, you have it deposited. And then when you get comments from the community, and then people are making suggestions for improvement, you could write up you can improve your preprint and then have a second newer version that you also upload. And then people see your history, like, okay, that was the first version, that's the second version. And then what also happens, so what happened to us, for example, when I was doing a meta-research study with some colleagues, actually a journal came to the leading author and asked if they could have this paper that we have pre-printed for their journal. So that's more like, I'm not saying it's an advertising tool, but if you really do good research, it can also be that some journals want you to publish that research in their journal.
And maybe to add a last one, there are also new initiatives that that focus on reviewing preprints. One of them, for instance, is pre-review, and so they're trying to add to, for instance, give suggestions to turn your journal club that you might have in your lab into a preprint journal club, where you actually take a paper that is published as a preprint and you sort of review it together with your lab, and then you can write up those comments that came up during your journal club, and you can write them up as a review basically, and that can be linked to the preprint. So since this is all still in academic terms relatively young and new, there you can see these things really change as we go. So the first preprint, at least for biology, was published, I think, 2015, around that time, so less than 10 years ago. And so you can see all of these things are starting to change. So the preprint reviews, the journals adjusting their policies. 10 years ago, it was a big no for most journals to publish, to review papers that were preprinted. By now, you can see that has changed for almost all journals, or at least I'll say most, I won't say almost. And those preprint reviews, they are now sort of the next wave, let's say. So this is now really the research community trying to find a solution to this question of, well, but then anything can be published on a preprint server. How do you know that it's good and high quality research? So this is a new way to try and address that question.
Yeah, thank you very much, Susan and Nelly. I think we've exceeded quite a time that we decided to go. And thankfully, we are going to have a number of sections on preprints. So I think a lot of the questions to be addressed during that session. So thank you very much for the insights today. It was wonderful seeing everyone here. If you have any questions, you can add it to the later part. Susan and Nelly would always look at that and answer the questions, and you can always refer to it, like they said, anytime for answers to the questions. But it's been a wonderful session today too. I think we would close the session now, and then we would see you at level 2 for reproducibility, when Susan and Nelly will also lead us, when we discuss more practical ways of making your research more reproducible. Have a wonderful day, everyone.
Yeah, thank you so much for coming. It was wonderful to interact with you. So thank you for all the questions. Hope to see you in the Slack or on the Etherpad answering more questions. Have a good rest of the day, everyone. Bye.
Yeah.
Bye.
Thank you. Bye-bye.
Have a great day.
Thank you so much.
Bye.
Thank you. Bye.
It looks like that.